Here we go. Advent of code. Oh. Mind your own business on a ship. Following report indicates that scanning outward from the submarine, depths of 199, 200, 208, 210. Count the number of times that it increased. Start equals int 0. Ints.each do int increases if int is greater than start I plus equals 1 start equals int puts I 1374. Oh no. Maybe. No. Count the number of times a depth measurement increases. Wow. Holy cow, 370. Sums of a 3 measurement sliding window. First and second. Sum equals ints 2 This is bad. Do index next. Some if ints index is greater than ints index minus and 418. Yay, I did it. Okay, that was 3 minutes. No, date. Hey, man, people are fast. Holy cow. Oh, this was first star. Wow. Incredible. Okay, I'll rewatch the video and see exactly what I got. All right, let's clean this up a little bit. That's not used. This was ints.each do int this was part 1. Oop. Let's make sure we restart our counter. Part 2I. Okay. Cool. And now what happens if I print leaderboard? Oh yeah. L. Let's see how I did against all the old Google people that I'm no longer working with. Okay. Hanging. Cool. I forget who that guy is. All right, still second place on the Google leaderboard. Or third place. That's third place. I can count. All right. All right, let's go over my solution. And actually read the problem because I did not read it. I jumped straight to the stuff. All right. All right, looks like the site's suffering a little bit. Wait, no, take me to the day. You're mining day 1 Sonar sweep. You're minding your own business on a ship at sea when the overboard alarm goes off. You rush to see if you can help. Apparently, one of the elves tripped and accidentally sent the sleigh keys flying into the ocean on a ship at sea. Before you know it, you're inside a submarine the elves keep ready for situations like this. It's covered in Christmas lights, because of course it is. And it even has an experimental antenna that should be able to track the keys if you can boost its signal strength high enough. There's a little meter that indicates the antenna's signal strength by displaying 0 to 50 stars. Your instincts tell you that in order to save Christmas, you'll need to get all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day. Second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. Okay, so that was just about the competition. As the submarine drops below the surface of the floor, I'm going to increase the font size. Drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby seafloor. On a small screen, the sonar sweep report, your puzzle input, appears. Each line is a measurement of the seafloor depth as the sweep looks further and further away from the submarine. For example, suppose you had the following report: 199, 200, 208, 210, 200. The report indicates that scanning outward from the submarine, the sonar sweep found depths of those numbers. The first order of business is to figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will get carried into deeper water by an ocean current or a fish or something. To do this, count the number of times a depth measurement increases from the previous measurement. There's no measurement before the first measurement. So it increases 199 to 200. There are 7 increase that are larger than the previous. How many measurements are larger than the previous measurement? So I did this. I got the start, and then I go over each value, and I see if it's bigger than the start, which is really, I can name this prev, and this is probably better. if int is greater than prev, increment I, which is the number of increases. Make sure to set prev after each one. Pretty simple, and that works. Then for part 2, there's a very, if you structure your part 1 a certain way, then your part 2 a certain way, is just changing 2 numbers. Part 2, considering every single measurement isn't as useful as you expected. There's just too much noise in the data. So instead, you consider sums of a 3-measurement sliding window, considering the above example. So this is one window, AAA, BBB, CCC. And you start by comparing the first and second 3 measurement windows. The measurements in the first window are marked A, their sum is whatever. Then the second window is B, so this is first window A, this is second window B. Sum is 618. Sum of measurements in the second window is larger than the sum of the first, so the first comparison increased. And you want to know the number of times that the sum of measurements in this sliding window increases. Yeah. Oh, okay, so these are the sliding windows. How many sums are larger than the previous sums? So not really key insight, but initially I was kind of confused and wasn't really exactly sure how to do this. What I was going to do is basically like loop over all of the possible starting points, which is this actually times 3? Why doesn't this error? Oh, because this is times. So this will loop through 0 to inStatLength minus 4 plus 3 is inStatLength minus 1. Yeah, so there should this be 2? No. Oh, wow. This should be 2. Wait, no. It's how many pairs of sliding windows are there? Yeah, this is correct. Because the key thing is when you're comparing sliding window B to sliding window A, the middle things cancel out. And you just end up, you're basically just checking if B is bigger, if this fourth one is bigger than the first one. And so, when if you're comparing adjacent ones, then they're length minus 1 pairs. If you're comparing things that are 2 apart, then there would be length minus 2. And so when you're comparing things that are 3 apart, because it's 0 or 1, 2, 3 things apart, they're length minus 3 pairs. And then we can just check the thing at the index plus 3 and the index and increment our count. And so really you can do part, if I just change this to 1, now I'll print out the same thing. So just changing this number from 3 to 1 will solve part 1. Cool. So that is part 1. Print leaderboard stub. 2021, day 1.